surface, like magma rises, and specific gases release in atmosphere, and the Earth heats up. The question is, how do we detect these changes in time to save lives? Turns out, the answer might be plants. You see, plants are like quiet detectives. They sense even the slightest changes in their environment, things we can't see or feel. When a volcano starts getting restless, it releases gases like carbon dioxide. This seeps into the soil and messes with the chemistry that plants depend on. Researchers discovered that plants react in fascinating ways. Some grow faster at first, thanks to the extra nutrients in volcanic soil. But as things heat up or gases like sulfur become toxic, plants start to struggle. Leaves wilt, trees die, and entire areas change color. Scientists track this using something called the Normalized Difference Vegetation Index, or NDVI. Fancy name, but it's basically a way to measure plant health from space. Healthy plants reflect more sunlight, while stressed ones reflect less. By comparing these patterns over time, we can detect warning signs of volcanic unrest. Take Yellowstone's Tern Lake, for example. For years, the plants here thrived. But then, something shifted. Trees started dying, soil temperatures spiked, and poisonous gases spread. It was like the forest was crying out, "Something's brewing underground." And it was something going on there. It was magma that was moving beneath the surface. Thanks to satellites, we can now monitor vast, remote volcanic regions. This tech lets us spot subtle plant changes months, even years before eruptions. Combine this with earthquake data and gas readings, and suddenly we have a powerful early warning system. But here's the cool part. Nature doesn't give up easily. Once the volcanic activity calms down, plants bounce back. New saplings grow, reclaiming the land. It's a cycle of destruction and rebirth that's as old as time. Plants and volcanoes, two forces of nature intricately connected. By studying these relationships, scientists are giving us tools to stay one step ahead of eruptions. Who would have thought the humble forest could hold the key to predicting nature's most powerful events? So,